All right, so now we're working on number 54 on page 90, and the problem begins. You have 2x over x plus 3 is equal to negative 6 over x plus 3 minus 2. And I want to point out that x cannot be equal to negative 3 because if you put a negative 3 in here, you're going to be dividing by a 0, and we can't divide by 0. So first thing we need to do is work towards getting a common denominator. I put the 1 underneath the 2. And I begin, and again, you don't need to on that one. So I begin by asking the question, what does this denominator need that this one has? Well, it needs an x plus 3. And you notice both of these already have the x plus 3's. So they're already in the same spot. And if you multiply these by 1, you keep them the same. So this denominator stays x plus 3. This denominator stays x plus 3. But this one gets an x plus 3 tacked onto it. And forgive me. So here's an x plus 3. And so we want to be multiplying by 1. That way we don't change the term. So we really put an x plus 3 here and an x plus 3 here. So if it gets put in the bottom, we got to put it in the top. And so writing 1 times this is redundant. So I'm just going to write x plus 3, and I'll have that x plus 3 in the top. Now, since our denominators all match, what I'm going to do is I'm going to multiply, and really what I'm using is the multiplication property of equality. Okay, so I multiply the left side by x plus 3, and I put parentheses around the whole side, and I'm going to multiply the right side by x plus 3. Now this is just taking a number and putting it over 1, and so the x plus 3 over 1 times 2x over x plus 3, well, the x plus 3's get to cancel, and you're just left with this 2x. What happens here, again, you put it over 1, and you multiply top to top, bottom to bottom, but you also have to consider the fact that we distribute. We have the multiplication relationship going on, or operation going on, and we have subtraction going on. And distribution occurs when we have those two operations being present at the same time. So x plus 3 gets into the numerator of this, and the 1 gets into the denominator. Now I don't need to write the 1, so it's really negative 6 times x plus 3 over x plus 3. And then we have the negative 2, and it has the x plus 3 already in the top, and then it's got the x plus 3 in the denominator. So when I put it here, I actually have it twice. Now I have 2 times x plus 3 times x plus 3, and in the bottom I have the x plus 3. Cancel, 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 leaving me with 2x is equal to a negative 6 minus 2 times the quantity x plus 3. Take your negative 2 and you distribute it to both, and you end up with 2x equals negative 6 minus 2x minus 6. Remember, that negative is going here, that negative is going here. And a positive times a negative gets us that negative, so we can treat it as subtraction. I'm going to add 2x and add 2x, so I get 4x. Negative 6 with negative 6 is negative 12. I'm going to divide both sides by 4, and I get x is equal to negative 3. Oh, wait a second. We said we can't get negative 3 as our answer because we can't plug negative 3 into here. Negative 3 plus 3 is 0. Negative 6 over 0 is undefined. So we can't have a part of our equation be undefined. So we will travel on down and we will say the empty set. Now sometimes you'll see him write it like that. Same difference. Okay. Now we're going to do number 67 from that same page. And I'm going to try and write it down a little bit more detailed than I have been. So I have x over x squared minus 9 minus x minus 4 over x squared plus 3x equals 10 over x squared minus 3x. First thing we need to do is factor our denominators. We need to figure out what factors fit for each one of the pieces. You'll see what I'm going to say, or see what I'm saying in a minute, I hope. So we have the x squared and minus 9. Now that's a difference of squares. So that's x plus 3x minus 3. We have a greatest common factor of x, so that's going to be x times x plus 3. We have a greatest common factor of an x, so that's x times the quantity x minus 3. And now my hint is ask, what does this denominator have that this one needs? And so basically what I'm going to do is I'm going to say this. What does this denominator have that this one needs? Well, the x plus 3 is there, and this one has an x, but this one does not have an x. So what I'm going to say is this one here is going to get an x. Now, what does this denominator have that this one needs? Well, this one has an x minus 3. This one needs an x minus 3. And similarly, if you compare this one to this one needs an x minus 3. So this one needs an x minus 3. The first one just needs an x. Now looking at this one, this has the x minus 3. It's got the x's, but this one's missing an x plus 3. This one has the x minus 3. This one has the x minus 3, but it needs the x plus 3. So what does this one have that this one needs? It needs the x plus 3. So I made the comment to that fact. This one needs the x, this one needs the x minus 3, and this one needs the x plus 3. And my next comment is, so we want to multiply by 1, so we put, whatever we put in the bottom, we need to put in the top. So this one needed an x, so I put an x in both. This one needed an x minus 3, so I put that in both. This one needs an x plus 3, so I put it in both. And remember that multiplication is commutative, so I can shift the binomials around. Okay. Now, multiply by the common denominator and all denominators will cancel out. In other words, what I'm going to do is the following. Over here, I'm going to have x times x plus 3 times x minus 3. But I put the entire side in parentheses, and it's going to distribute to both parts. And so this is going to be presented here, this is going to be presented here, and so what happens is your denominators all cancel out. Now you also have to do it on the other side. What you do to the left, you got to do to the right. Okay? So that's the multiplication property of equality. So you have that denominator getting canceled out. So you're left with x times x, which is x squared. You have the subtraction. We've got to deal with that in a minute. Then you have the x minus 4x minus 3, and then the 10 times the x plus 3. So when I FOIL this out, I want to remember that that negative is going to change signs throughout. So I've got x squared minus 3x minus 4x plus 12, distribute the 10. And so now I have x squared minus x squared plus 7x minus 12 is equal to 10x plus 30. These drop off. Add 12, I've got 42. Subtract 10, subtract 10. I've got negative 3x equals 42. I'm going to divide by negative 3, and I've got x is equal to negative 14. So you can see it written like that. Sometimes you'll see it in set builder notation, where they put this little like pretty curtain, and then they write x is such that, that's this piece, x is such that x is equal to negative 14, and they close it off. Okay? Sometimes you'll just see them put it as it's the set negative 14. All right. Now, if I go back to the beginning and I start talking about domains, I can't have 3, I can't have negative 3, and I can't have 0. Those are the 3 that I have to avoid. Well, the negative 14 is not one of those values. So the next piece I should do is I don't have time on my videos because I'm limited to 10 minutes, but I should take this and I should plug it in for x in each one of these spots. Plug it in for x in each one of these spots, and we will get the correct answer. We'll have a true statement. All right. Hopefully that helps. Talk to you guys in a bit.